So welcome to Caltech, or welcome back to Caltech, for those of you who have been here and been here recently. So, in particular, a very warm welcome to all of our fellow EFRC researchers. So today's workshop is a project of the Light Matter Interactions workshop, Light Matter Interactions in Energy Conversion, EFRC, centered here at Caltech. And I'll say a little bit about that as we go along. And the goal for today really is to be focused on fundamental issues in solar energy conversion. And our program is going to essentially set the tone with some overview presentations that will frame many of the issues associated with solar energy conversion, photovoltaic energy conversion, and energy balance and energy accounting in general. And then what we've done in the afternoon is to structure breakout sessions. And the intent here is to be very interactive. And the speakers have all graciously agreed to remain this afternoon and interact with the participants in the workshop in 3 breakout sessions focused on fundamental limits to photovoltaic efficiency, light trapping and concentration, and third generation photovoltaics. And the scheme of this is that we will have breakouts running in parallel. You can go to any one you want at any time. It's like going to class in junior high school. You can go to one class and then another class and another class, and you can choose which breakout you want to go to at which time. And they'll be located in 3 rooms, which are, I'll identify the location for you. And the goal there is to really bring all of your questions and begin a discussion in a very interactive manner. So this morning we're going to be hearing from first Professor Eli Jablonovich on fundamental limits to light absorption and efficiency in photovoltaics. Eli is a professor at University of California, Berkeley, and a veteran of the photovoltaics field. Dick Swanson, who is well known to many of you as a foundational figure in photovoltaics and the architect of the sun power technology, is going to be telling us about efficiency limits and cost challenges in photovoltaics. I'm going to give a survey of many of the issues associated with thin film photovoltaics. And Chris Hansberg from Arizona State is going to describe to us some of the challenges that are embraced in so-called third generation approaches to photovoltaics. Then we'll have lunch, then breakouts, and hopefully lots of learning and discussion. So one thing I wanted to just mention to you is that we're here on the Caltech campus, and you're here in a brand new building, an astrophysics building, with here right on California Boulevard. The Caltech campus is very compact, and we have a gravitational theory of geography. Uphill is north on the Caltech campus. We're on a glacial moraine from the San Gabriel Mountains. So all you have to do is walk uphill across California Boulevard here to the breakout rooms in 104 Watson, 125 Steel. The Annenberg building is just behind the Watson building. So, and there will be a group of Caltech natives who can help escort people who are uncertain where to go, and we'll make sure that everybody gets to their right rooms after lunch. Before lunch, all of our lectures and the lunch will be here out on the patio of the Cahill Center. So I wanted to first just tell you a little bit about the Light Matter Interactions EFRC, since we're your host. And our EFRC is focused on fundamental optical principles and phenomena relevant to solar energy conversion, the design of optical materials and devices. So it's really not focused so much on solar cells per se, or the detailed materials physics issues and electronics issues with materials, but really the photonics issues associated and photonic design principles. And the EFRC is a collaboration of Caltech, Lawrence Berkeley Laboratory, and University of California, Berkeley, and University of Illinois. So it's really just to let you know, our focus is on taking the existing disciplines of materials physics, materials chemistry, and applied mathematics, and the emerging disciplines of metamaterials, plasmonics, and underlying electromagnetic theory, together with the spectacular new techniques we have available to us for nanofabrication in 2 and 3 dimensions, to build structures with complex architecture that allow light trapping and spectrum splitting beyond the classical limit, light focusing for efficient energy conversion and upconversion, and probing extremes of spontaneous emission and absorption, really focused on the DOE grand challenge of making inorganic structures that have function and property rivaling the marvelous properties of living things. So the research directions, as I mentioned, are focused on upconversion and photon conversion, finding limits to absorption and spontaneous emission, establishing transformation optics principles that are useful in solar energy conversion, and developing complex dielectric and metal dielectric architectures and, in fact, light-driven synthesis processes for generation of materials. And this is the cast of characters: Paul Alivisatos, Oscar Painter, myself, Ralph Nuzzo, Paul Braun, John Rogers, Jennifer Lewis, Eli Yablonovich, Nate Lewis, and Zhang Zhang at Berkeley, Illinois, and Caltech. So I wanted to also tell you a little bit about some of the other energy research activities and initiatives here at Caltech, one of which is the Resnick Institute, which is a Caltech's Energy Institute. It is now Caltech's largest endowed program and a very high priority for the campus, and it's focused on both scientific research, communication, and events like today's workshop. Another scientific initiative is the Chemical Bonding Center, NSF Chemical Bonding Center, that is focused on solar fuel generation. This is directed by Harry Gray, and it's focused on developing photoelectrochemical structures that have inorganic constituents, both light absorbers and catalysts and membranes that allow for charge separation and ion transport to enable oxidation and reduction of water and carbon dioxide to yield chemical fuels. So now turning to the topic of today's workshop. So why should we have such a workshop at the moment? And I guess the one way to answer this is to look at history. As professors tend to think of things in rather venal terms, think of things in terms of financial support. And of course, it's financial support that drives the exciting science that we're able to do. And it's interesting to look at the history of federal research for energy research and development, and note that there was a previous renaissance in photovoltaics and solar energy, as well as other forms of renewable energy, that corresponded with a rapid escalation in oil prices in the late 1970s, a period of great economic uncertainty. And then that was followed by a sharp reduction in the funding for renewable energy research. And you might notice the parallel here between the funding levels for renewable energy research and the price per barrel of oil here in the on the world market. And so in the 1980s, the oil dropped to about $25 a barrel, and we lived in a temporary paradise of cheap oil. And so, of course, nowadays we've gone through another oil price spike. Oil is not currently at an all-time high price, but everyone is extremely conscious of the price of oil. And moreover, we have, courtesy of the initiatives by the Department of Energy, have a newly established set of energy frontier research centers. And this is really a new initiative for the basic energy science side of the Department of Energy. It's the first time that a large number of large-scale centers have been formed. There are 46 new EFRCs. And if you do the math, that corresponds to about 2,000 new renewable energy researchers working in the United States. And I think that's a spectacular increase. And if you also go through and you identify and look at the self-identified EFRCs that are working on solar energy conversion in some form or another, there are 18 of those, and corresponding to more than 600 new basic researchers in solar energy conversion. Also, in the last few years, interestingly, prior to the infusion of support by the Department of Energy, there was a period which I think where the private investment dwarfed the federal investment, and that fostered the formation of more than 100 early-stage companies in the United States in solar photovoltaics and concentrating solar power. So that really brings us to the point of today's program, that we have a lot of new people coming into the field, many young people who weren't around during the last time that oil reached its record high price, and solar energy conversion was both a subject of intensive scientific research and sort of household conversation. Without further ado, I'd like to go ahead and get started and invite Professor Jablonovich to the podium. Eli is going to tell us today about fundamental limits to light absorption and efficiency in photovoltaics, a field with which he has been in which he has been very active throughout his career, spanning more than 25 years.